We have a simply supported beam. It's subjected to a concentrated load of 600 pounds, located over from A, a distance of 5 feet, and from B, a distance of 7 feet. It has a pin connection at A and a roller at B. We are to draw the shear and moment diagram, which is a graphical representation of what's going on inside that beam. But first we want to draw the free body diagram and then solve for the reactions at both A and B. So go ahead and pause the video and let's go ahead and solve for those. All right, so the results are we have a force at A upwards of 350 pounds and B upwards of 250 pounds. Next, what we're going to do is we're going to draw first the shear diagram. So I'm going to draw lines straight down at points A and B, which are the span of the beam. I'm going to also project down points of interest, in this case the 600 pounds, which will be dashed. So the first thing we're going to do is, after we've got that set up and labeled for our shear, I'm going to draw a line left to right, horizontal, which will represent our baseline or datum, which is 0 shear going on there. On the upper side would be plus, on the bottom side would be negative. So all we have to do is we're going to move from left to right to draw this. So the first thing you look at when you're looking at the beam is that we've got a force, reactionary force at A, going straight up for a weight of, or a force of 350 pounds. So you draw from the 0, you go straight up 350 pounds. And then if you look at the beam from 0 to 4.999, there is nothing going on, so it stays the same. You draw it straight out and over. And then as soon as it hits 600, okay, it's going to drop straight down a distance of 600 pounds. So it's going to be down to negative 250, okay? And then, again, it's going to move from left to right. It's going to keep going at that negative 250, and it's not going to do anything until it gets to the support at B, and it has a force of 250, and it goes right up, and it gets to 0, and that's what we want. All right, now what we're going to draw is the moment, okay? So we're going to draw the moment diagram, and we're going to take some cues from what we got on the shear. If you look at the shear diagram, we got 2 blocks. Now, I quickly label the top block that's above the datum positive and the one below minus. I also note that the area of those blocks are 1,750. We get this for the top block, that's 350 times distance 5. And for the bottom one, it's 250 times 7. Okay, and that's what we want. They're going to equal each other out. Now, to draw the moment diagram, we're going to take some cues from what we draw on the shear. The first thing I'm going to realize is that at A, there is no moment, so I start at 0. Then I'm going to identify what happens at that dashed line, and it reaches up to a magnitude of 1,750 foot-pounds. Now, what do we do? How do we draw the line from left to right here? Well, the thing we're going to take our clue from is the shape of that box there. So it's a box, it's flat. What that means is the slope of that line is constant, okay? And it has a slope of the volume of that box. So the slope is the volume of the box. So it gives me an idea. So if it was a small box, small volume, or small slope. So it's going to be a straight line. And then we're going to draw, then it goes up to, so we got a positive 1,750. And then we got to subtract 1,750, and it's down to 0 at the end at point B. And again, we take the cue from our shear diagram as the shape. Okay, it's a downward because it's a negative value for my shear from the point of where the 600 acts to B. So we know it's going down, and it's going to go down from the 1,750 all the way down to 0. So it's a straight line down there.